After some given information, we find that our goal is to find an exact value of the sine of alpha minus beta. So there's a lot of stuff in here, but I know that if I want an exact value for a sine function, I'm going to need an identity for that. And it's this one, the sine of a difference. So that goes sine, cosine, cosine, sine. The angles go in order alpha, beta, alpha, beta. For the sine of a difference, the sine SIGN in between the two terms is the same as what we're trying to do. It's a difference, so I'm going to put a difference. Okay, so we got the identity. Here's what we're looking for. I'm going to need sine alpha. Well, cool, I have that. I need cosine of beta. Well, I have the tangent of beta, but not the cosine. I need the cosine of, and the sine of beta. So out of all that, all I have is the sine of alpha, but the good news is we can find the rest of those pieces to this puzzle. The next thing I'm going to do is come up here and look at this given information and notice that alpha is between pi over 2 and pi, which is the long way of saying alpha is in quadrant 2. Similarly, beta is between pi and 3 pi over 2, which is the long way of saying beta is in quadrant 3. And both of those things are important because sines and cosines have different signs with a G in different quadrants. So we're going to need to know that. For alpha, I know sine of alpha is 8 over 17, which is y over r. And that's great, except for the cosine, I need x. The good news is, if I know y and r, I can find x. Pythagoras has been kind of lurking in the background for a while here, but time for him to come back out. So I got x squared plus y squared, combination of y and 8, equals r squared. And if we do a little squaring, a little subtracting, and a little square root, we're going to get the value of x is 15. Since we're in quadrant 2, x values are negative in quadrant 2, so that's actually negative 15. And now I know the cosine of alpha is x over r, negative 15 over 17. Okay, so we're half done. Now we need to look at beta. Have the tangent of beta is 3 over 4, which is y over x. But beta is in quadrant 3. In quadrant 3, x and y values are all negative. So I'm going to say x it actually has a value of negative 4 in quadrant 3, and y has an actual value of negative 3 in quadrant 3. We still need r. But Pythagoras to the rescue yet again. X squared plus y squared equals r squared. And if we square them, add them together and take a square root, we get a value of r of 5. And that's positive. R is always positive. Okay, I know x, I know y, I know r, which means I can find the sine of beta is y over r. And the cosine of beta is x over r. Which is not what I meant to write. We're going to put the actual values in there. Cosine of beta is x over r, which is negative 4 over 5. Well, now we have all the pieces to the puzzle. We just need to put them together. So here goes. Sine of alpha minus beta is sine of alpha cosine beta minus cosine alpha sine beta. The denominators are the same, both of them. 17 times 5 is 85. 8 times negative 4 minus negative 15 times negative 3, positive 45. Little addition, and we're there. Let's see, what do we got? Negative 77 over 85 is the value of sine of alpha minus beta.